Okay, so here we have an application from chemistry. You may see this under the topic of mole-to-mole conversions in a typical intro to chemistry class. It looks very different, but I'd like to show you in a few moments that this is really very similar to the oranges example we just completed. So you have a somewhat complicated looking chemical equation, but at the moment all we have to be concerned about is that the way we're going to read this is basically look at the coefficients 2 units, and typically we're going to talk about moles. So let's say 2 moles of hydrogen plus 1 mole of oxygen will produce 2 moles of H2O or water. So the only thing that we need to pay attention here, because this is just trying to point out to you ratio and proportion things that from chemistry. So just look at this, that when the coefficient here is 2 moles of that quantity, this coefficient has to be 1 mole of oxygen, and this coefficient has to be 2. And it's given that in a chemical reaction, the ratios of substances in moles used up and formed must stay the same. So these ratios will always be the same. The 2 to 1 to 2 ratio in terms of moles will remain the same. So that means, to answer the question here, determine the number of moles of oxygen that would be required or needed to react with 4 moles of hydrogen. So we're going to use the same ratios. So we're given 4 moles of H2, and we're trying to determine the number of moles of O2. So the ratio between H2 and O2 based on the given coefficients in the given equation was 2 to 1. So now they gave us 4 moles of H2. And again, the typical ratio was 2 to 1, or just take half of that. You're going to need half as many moles of oxygen. So if we're given 4, here we can see a clear pattern. Therefore, this has to be 2. In other words, for 4 moles of hydrogen, we're going to need 2 moles of oxygen. Okay, and also the question asks, how about how many moles of H2O or water needed? And the typical units conversion there was, we were given hydrogen, so 2 moles of hydrogen will produce 2 moles of water. So the ratio there was 2 moles of H2 produces 2 moles of H2O. So here we are given 4 moles of H2. So as you can see, it has to be exactly the same based on the given proportions. So it'll be 4 moles of H2O. So that is the answer for how many moles of H2O will be formed, and that is the answer for how many moles of oxygen will be formed. Let's take a look at another example. As a matter of fact, it's the same one, but we're going to have a few more parts to it now. So when 4 moles of hydrogen that was given to us, number of moles of oxygen produced or reacting with H2, we've determined that to be 2. I'm just filling the table based on information obtained above. And then 4 was the answer for the number of moles of water. Now let's see that. Look at the table. Now we're given 3 moles of oxygen is given. Then can you fill in the blanks? As a matter of fact, can you fill in the remaining part of this table and then come back and check with us for the answers? And I will just copy down the given ratios. It was 2 to 1 to 2. So this is always going to remain constant. This ratio 2 to 1 to 2. So if you take 2 moles of this substance, 1 mole of this, resultant will always be 2 moles of that. So now we know this one is 3. So can you fill in the blanks for the next 2 boxes? So clearly 1 to 2 ratio, you have to double it. So this will be 6 moles of this substance. And same thing here, 1 to 2 ratio, this will also be 6. Now if this is the given quantity, 0.4 moles of H2O, from there to there, what should we do? Divide by 2, right? Because it's a 2 to 1 ratio. So that will be 0.2 or 0.2 moles. And from there to there is a 2 to 2 ratio. That means the same amount. Whatever you use here will be the same there. So 0.4 or 0.4. And over here again, 7 is given. From there to here is 2 to 1 ratio. So take half of that, 3.5 moles of oxygen will be needed, and from there to there is the same ratio, or just 7 moles of hydrogen needed. Okay, we have another example that is somewhat similar. So this time a more complicated looking equation, but the idea is still the same. You have 4 moles of NH3 or ammonia plus 5 moles of oxygen, resulting in 4 moles of nitrogen oxide and 6 moles of water. So the question is, if you begin with 8.0 moles of ammonium, how many moles of the other 3 substances are you going to need? How many moles of oxygen can react with that? And what will be the resulting nitrogen oxide and water values? How many moles of those will be produced? So please take a moment to try this on your own first and then come back and check our answers. And the given ratios are 4 moles of this quantity will react with 5 moles of this quantity, resulting in 4 moles of this and 6 moles of water. Okay, now the first one is actually pretty simple because it's an even number, a whole number multiple. So like from 4 to 8 is exactly double the amount, right? So can you see what the other values are going to be even without having to use any formulas or equations or conversion factors? It's just going to be, if this is 8, everything has to be doubled, right? The ratio was 4 to 5, so it should be 8 to 10. And here it's 4 to 4 ratio, so this should be 8 to 8, so it should be the same thing. 8.0. And here, again, it's 4 to 6 ratio. So we need to know, once again, it's just being doubled. From 4 to 8, it's been doubled. So this is going to be 6 to 12. And let's check significant figures. Because it was given 8.0, had 2 significant figures. This should also have 2 significant figures. So I'll put a period there or decimal place. 8.0 and 12 both have 2 significant figures. Okay, let's check the next one. 15 moles of water. That will require how many moles of these 2 substances and how many moles of this will be produced along with 15 moles of water. Okay, I'm going to begin with the first one. And notice the moment you determine the first one, you will already know the answer for the third one, for the nitrogen oxide, because those are 4 to 4 ratio. So whatever this is, this will be exactly the same. And I'm going to follow the approach from chemistry as I do this example. So we are given 15.0 moles of H2O. We're trying to end up with an unknown moles of NH3. And we need to write a conversion factor over here based on the given equation. What is the conversion factor between NH3 and H2O? So it was 4 to 6. So I want to put the H2O moles on the bottom, so the moles of H2O will cancel, right? So given information tells us 6 moles of H2O will be produced when 4 moles of NH3 are used. Let's cancel the common units, so moles of H2O, moles of H2O. And the answer is 15.0 times 4 over 6 moles of NH3. And if we simplify that, we're going to have 60 over 6 or 10.0 moles of NH3. And here I've rounded to 3 significant figures. The reason is the given expression had 3 significant figures, and we're assuming that this is the only measured quantity here. We're assuming that the given coefficients of the equation are exact values, and they're not going to limit the number of significant figures in our final calculation. So the only thing that will restrict is the given measured quantity. So I will fill out the table with the value we obtained. We have 10.0 moles of NH3. So here we have 10.0. And remember the 4 to 4 ratio in the given equation. So these are exactly the same amounts. Whatever this will be the same. So 10.0 moles of NH3. That means this will be 10.0 moles of NO. So can you now go ahead and figure out this value? How many moles of oxygen will be needed in this equation? And here is the answer to that question. Number of moles of oxygen, that's the question. Given was 15.0 moles of water. We put the ratio, the conversion factor that we know between between water and oxygen. The ratio was you need 5 moles of oxygen to produce 6 moles of water. 5 moles of oxygen for 6 moles of water. And the way we put this is because you want the moles of water to cancel. So we're left with moles of oxygen. When you do the math, you get 12.5 moles of oxygen. So you can fill in this space with 12.5. And that concludes our presentation part 1 on ratio and proportion.